So the last enemy that we're going to set up is going to be our kind of barking dog enemy that's going to target the player's position, and in turn kind of only begin to bark when it moves within a certain range. Now this requires a couple of kind of technical things to set up. So we're gonna first things first. We go to our level. We just need to change what enemy is being spawned. And you'll notice with this, rather than being spawned in the pipes, at a specific location, I've set a random location within a certain range to determine its spawn point, so they're not just appearing at the same point. Yeah, so the first thing that we're going to get implemented is I'm going to set up like the kind of communication between the player and its location and the enemy itself. So the first thing that I need to do is I need to set up. Well, let's tell you what. Let's get it moving towards us first. So if we go to motion, the chunk of code that we would need to get our character to, well, our enemy to move towards the player, is this little chunk of code here. And what? Well, there's a couple of different options, but let me just quickly check very quickly whether it's X speed or whether it's... Yeah, it is. It is X. It's X speed. You could either use the push self gently chunk of code, or you could use X speed and Y speed. So for this, just to keep things in kind of in combination with the tutorial, yeah, I'm just going to use these. Now, the problem is that I need to know where to send this. And the issue with that is that I can't refer to the player within the enemy currently. So I can't just like click the drop down and be like, oh yeah, select the actor that we're needing to talk about, because if I do that, it doesn't bring up the player as an option. So what I would need is essentially a value that I can kind of call on, and that would be a game attribute. Now I've already created these, but it's basically a number-based attribute, and it's the player X and the player Y. What I'm going to do before I add these in is I'm going to set them up in the player first. So these values, I'm going to set these under always, and the reason I'm going to do that is so it's constantly checking for its location. If I don't do that, for example, just set it at the beginning of the game, or if I set it, less often, then it's going to have a less accurate kind of knowledge of where my player is going to be. Which, for some games you might actually find that useful. So, for example, if you made that as you got further and further away from, the enemy, that its ability to track you would get worse and worse the further you got out. That would be actually quite useful. But yeah, so what I'm gonna do now is I've set these up, so it's setting the player X position to X of self and setting player Y position to Y of self. And this is within the player. So those two are now recorded and will constantly be recorded for us to use in the enemy. Now, what we want to do, well, the issue that we have is if we just use player X and player Y, what's going to happen is these are both positive values. So whilst they might travel initially in the direction of our player, what's inevitably going to happen is if, for example, it misses the player, it'll just keep going. It won't be able to turn around to kind of hit the player. So if I just quickly show you an example. These characters will probably behave a little bit bizarre. They'll kind of move down towards us and probably, possibly pass us. They might not, they might miss us completely. But what we need to do is essentially, factor in its location in relation to. So here we go. So you can see that there, like these characters are literally, coming close-ish, but none of them are really lining up to the player. And the reason for that is because we need to essentially factor in the position of the enemy into this. And the way we do that is we take the value of the player and we deduct the position of the enemy off of it. And what that gives us is a positive or negative number. If you watch the Space Shooter tutorial, I go through this in some depth. I draw up some nice diagrams and all sorts of stuff. I believe it's video 9A and 9B that goes through enemy movement. And it covers this in this particular chunk of code in quite some depth. So if you want to take some time to look at that, I would suggest watching that video. So yeah, the other thing you might have noticed is that we were going stupidly fast. What I'm going to suggest, as we did with the directional enemy, is that we reduce this number by dividing it, so that it takes a little bit longer to do this stuff, and it isn't just shooting across the screen as it was before. So now if we test this, once I've connected this into place, that is. There we go. Once I've tested this, we should end up with a sensibly moving enemy kind of heading towards our location. And what's neat is that you could actually switch the player X and the enemy X around, and what that would do is it would actually repel the enemy from your location. So no matter how hard you tried to get to the player, it would continually try and reach you. So no matter where it is on the screen, it's always going to try and... Whoa. Yeah, it's going to try and reach my location. Cool. Now you'll notice that they're looking kind of just smug at the moment. They're not really kind of reacting to, if I'm within range. So what I'm going to do is I'm going to now create a chunk of code that's going to essentially change its animation if we're within a certain range. So I'm going to switch animation to bark. Now if I didn't have this if here, it would just constantly do that. What I want is only if it's within range. So it'll be something like if a certain number is greater than another number. Oh, actually no, it'd be the opposite way around. Apologies for that. We'd be checking to see if two numbers combined were less than a certain amount. Now, the two numbers that we're going to be working with for this, just to make it nice and easy, is we're going to work with the player Y and the enemy Y. Now, this, if we give it this, this will work in a way, but not in the way that we want. Because what it'll do is, if the player's location is lower than the enemy, so if it's higher than the enemy, it's going to trigger the barking. But what we want is to have a range. You know, so it's when it's within a certain value. So what we would want to do for that is we'd want to take the position of the player and the position of the enemy, deduct one off the other, and use that as the value that we use for this. The only thing that we would want to add to it is this little chunk of code here. This is absolute value. The reason that we would want to add this is if this becomes a negative number, then it's definitely going to be less than whatever range we set. So if I wasn't particularly planning to do like a demo with this, but I might as well, just super quick. So if you imagine this is your player, this is your enemy. That's a really awful color, I'll apologize. Okay, so player and enemy. What we're going to do is we're going to take the player's position and we're going to deduct the enemy's position off of it. That might sound like we're doing the same thing as before, but what we're going to do is we're going to find the value of what this is and use that as a range. So at the moment, let's say that the player's position is at 0 and the enemy's position is at 50. Okay. So if we deduct this one from the other, the value that we'll get from it is going to be negative 50. Now the issue with this is if we try to ask the computer and say, hey, so if the players, these two values added together, if their total value is less than, let's say, 30, trigger this event. You know, we're just measuring meters on either side. As in we're measuring a unit on either side, but we're not factoring in that. Whilst in the real world you'd measure it in something like steps, for example. You know, so you'd say like if I'm 20 steps from you in any direction, you know, this code would trigger. But when you're dealing with a 2D game and, you know, a 2D space, you have positive and negative scales for figuring out where things are in relation to one another. So for example, you know, if the enemy was over here, well, in this case, like you've got, you know, negative 50 been brought out as a value. Now, whilst this would be useful for setting its speed, what we want to do is make this an absolute value. And what an absolute value is basically a way of kind of making whether it's a positive or negative number redundant and purely just, you know, kind of capturing the numeric value of it rather than, you know, whether it's a positive or negative number. Now this is really useful because rather than, if I just quickly wipe this clean, if you imagine the scale that it's having to figure out, so here's the player, here's your enemy. At the moment, what would happen is this is the distance that these two are apart. Whoops. Now, when you get within this range, trigger some kind of event. The issue that you would have if we didn't have access to an absolute number is that if the number that we were talking about was negative, it would definitely be less than that amount because it would be somewhere over here. But because we're only measuring, we're only measuring one way, it would, even if it was out of the range of 30, but in the opposite direction, so it was like somewhere over here, it would still be triggering code because it would be a negative number rather than a positive number. Apologies if I'm not making that clear. I'll add, but let's just do a quick example to kind of make this a little bit easier to comprehend. So if I just going to give this a different color just to make it a bit easier to distinguish. So this is the player. This is the player's location, and when the enemy gets within no, that didn't work. Gets within. We're basically saying gets within this range of the player. Trigger this event. Like the enemy will start barking or whatever. Let's put some numbers to these values. So let's say the player's at 0. Let's say the enemy is at 50. So what we're really looking for is if these two numbers combined, it makes a number that's less than 30. And the issue is when we do combine these two numbers, what we get is a number somewhere over here at negative 50, which even at the point that they are now, that's going to automatically make this enemy think, oh, I'm active. I'm meant to be doing the bark animation. But if it's an absolute value, rather than being over here, it's exactly where it needs to be, which is, it's calculating at its pure value, which is 50, and then as it moves closer and closer, it'll keep track of that until it hits that trigger point, and then it'll change what we need of the character. Hopefully that's a little bit clearer. So by connecting this into place, whoops, that should only when it's within a range of 150, or so as in if it's less, if this absolute value is less than 150, will it begin to bark? And if it wasn't so difficult to actually get past these enemies, and the fact that you've got enemies raining down from elsewhere, we could also throw in an otherwise as well, which would essentially, change it back to a neutral face if it moved out of range. But for the most part with these enemies, they'll... so let's give this a go. Bark, 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 bark. With these enemies, it's kind of pretty hard to get past them. Now, the only thing that we want to add, which is kind of evident, is even though they're moving towards me to the left, they're still facing right. Now, the cool thing is that because we've already set up this piece of code for our earlier enemy, we can just kind of copy and paste this across. So if we go to our enemy basic, we have this nice little piece of code, which we actually don't need all of it. Like, what we can do is we've already got the animation set up, so we can kind of refine this a little bit. And cut out the bits that we don't need. So what will happen now is, based on which direction it's facing, and based on what speed it's going, it will then determine which way it faces. So we should now have an enemy that follows the player, that changes its animation based on how close it is, and also changes the way it's facing. So let's have a look. Whenever it actually spawns. There we go. Bark, bark, bark. Sweet. Let me just very quickly check to make sure there's nothing else. There is the colour that's been changed, but once again we covered that in the last tutorial, but I'm 95% sure that's covering everything. Yeah. This is kind of the core code that we're needing to look at. I've actually included the otherwise in this. We might as well cover it. So I've in the other code I put together, I've actually included an otherwise here. That I suppose it's good practice just to have the alternate animation that if it's not within range, just go to idle. And yeah, other than that, let's just add all 3 enemy types back in. Remembering to put that random setter back in place. And we should have 3 completely different types of movement figured out in Stencylworks. Yeah. So if you just give this a moment, you should be able to see all of these in motion. And yeah, if you have any other questions about enemy movement, feel free to either comment or just drop me a message about what you'd like to kind of learn. You'll notice as well that the rate of enemies is a lot less than what we were used to at the beginning of the game, because of the fact that we changed it from spawning an enemy every 1 second to every 3. So this is actually quite manageable. Yeah. But let me just very quickly fix that. But that pretty much wraps up this tutorial. Even with the stuff that we've covered, there's still so many different things that you can do. One of my kind of favourite things to change with something like the enemy target is having something like a very simple trick of, if you want to have an enemy kind of repel from your location, what you could do is, let me just quickly show you these all in motion together. Whoa. Whoa. Yeah. If you wanted to, for example, have the enemies be repelled from your location, what you could do is you could switch these around, and that would do the opposite. Now, if you had like if you were wanting to kind of make your enemy feel like a little bit cleverer, what you could do is you could have some periods of time where it would follow you relentlessly, and you could maybe have it that if it its health reached a certain value, if it had like only 5 health, 1 health left, it would go from chasing you relentlessly to running away. And by switching these pieces of code around, you could essentially do that. I'll just tweak the spawn location of these enemy targets to kind of let you see this in action, of them kind of spawning in the middle and then running away. And yeah, like there's no reason that you couldn't mix and match these behaviors. So for example, having it that if you have an enemy that targets you, and if it collides with a tile, that it makes it jump, or it makes it do something. Whoa. Come on. So you can see that these enemy heads are running away from me now, rather than what they were doing before, which was targeting me. Seems to be a lot of these heads been spawned. Wow. Oh wow. Okay. But yeah, that pretty much wraps up this tutorial. As I said, if you have any other questions, there we go. Lots of fleeing heads. Yeah, the way that you could kind of alternate between these, just as a real quick extra thing, is if I wanted it to alternate between coming towards me and then running away, what I could do is I could combine these two. So I can make it if it. Oh wait, have I just copied that twice? Yeah, whoops. You could use something like either a enemy state as an attribute, which would randomly change every 3 or 4 seconds. Yeah, that's because I altered something mid compile. You could have like a random attribute that would change every 3 or 4 seconds. That would change how it was behaving. You could change it based on its health. You could change it based on if like an alarm's blaring out, whether you've so then all the enemies come to you, and if not, they just kind of become dismissive. Yeah, like there's so many different things and combinations that you can kind of create with this stuff. So yeah, there's no reason why you can't experiment. Oh, there we go. So you can see with this now, if I rise up high enough, the enemies won't target me. But it's surprisingly hard because of all the enemies. Yeah, it's too difficult for me to kind of demonstrate this because it's Now you can see some weird stuff happening with that, because there's a point where, for example, with the setup I've got, there's a kind of a leeway point where the enemy, you see it kind of flickers when it gets a certain range away. That's because it's kind of let's see if it. Yeah, you can see the flicker point there on the enemy. That's because it's hitting that range of 150, and it's getting stuck because it can't figure out whether to run away or not, or attack the player. So yeah, that's kind of covered a bunch of different kind of weird combinations and extra setups as well. Apologies if you've been kind of clinging on for some useful information. This isn't what you need. But yeah, I just figured I'd talk about it. And yeah, if there's anything else you need, just let us know.